Hi, I'm Brett Nixie from the Barossa Improved Grazing Group, and I have today with me Peter Toome from TOIP Pty Ltd. How are you, Peter?
I'm very well, thanks, Brett. It's great to be with you again.
No worries at all. Just as background, as part of BIGG's Soil Moisture Monitoring and Grazing Systems project, which is funded by the Adelaide Mount Lofty Ranges NRM board, we've had 4 weather stations that have been installed in the Barossa region, one at Flaxman Valley, one at Caton, one at Canunga, and one at McColta more recently. First ones went in 2013, and Peter's actually been hosting our data since then. That data includes rainfall, temperature, relative humidity, wind, and soil moisture. And so Peter's in a good spot to actually go ahead and analyse some of that data, and he's come up with some interesting graphs related to variability, particularly soil moisture and also rainfall. Peter, have you put a short presentation together to be able to show us that? Would you be able to give us a bit of a few insights, please?
Yeah, great. Thanks, Brett. What we're going to do is have a look first at the rainfall information. So this is coming from the station at Flaxman Valley. We're interested in rain because that's the primary input you've got in a dry land situation, whether it's cropping or pasture. We're interested not just in how much rain we get on a day or every 15 minutes, but we're also interested in what you get over a period of time. What do we get in a week? What do we get in a month? What do we get through the key parts of the growing season, so from April to October? And once you have that information, it's interesting to compare one period to another. You may be interested in comparing, in particular, one season to the next season, so that you can look at the differences that's made to the pasture growth and how that's affected dry matter production and how you're going to manage your grazing. So we're going to start with the first full season that the sites went in. So this is 2014 data from Flaxman's Valley. So what we've just done is taken the rainfall information from the site and then plotted it accumulatively. So the large steps here are obviously when we get reasonable rainfall events. The flat lining is when there's no rain. And so you get a bit of an idea of when the rain's coming during the season and how much you've got as a total. You can see that the rain started here with a bit of a break in April. We had good rains through, again, the end of April, and then rains through till the end of August. And rain pretty much stopped there for a while. And we saw some later rains in November and then rains in January, finishing the season with 624 mil. Now, Flaxman's Valley is a 600 mil a year rainfall area. So that 600 mil is probably pretty much a good on par rainfall year. So if we move along now and compare that with 2015. So 2015 is here in red, the 2014 rain is blue. And you can see the difference in there, not just in the total, 624 mil versus 535, but we can also see some changes in the timing of the rain. At the start of the season, the rain came a little bit later. The break was a little bit later in the year. Through winter, pretty much similar pattern, but with lower rain. It did cut out around the same time, but we ended up 20% down on the previous season. What happened then in 2016? So 2016's the green line here. So season break was later. Again, season break wasn't till May. But there wasn't many periods without rain through this season. There was a bit of a window flat line there in late July, August, but you can see rainfall kept coming strong right through into the summer period, and we had strong rains in December, January. Finished the season with 740 mil, so well above the average, and would have been a very good growing year. 2017, so now we've got the 2017 in the other green colour. The difference between 16 and 17, we've gone from 740 mil to 440. That's a big difference. The season break came later, and the rain was concentrated in a small number of heavy events in June and July. You can see that there wasn't as much rain late in the season. Late spring rain, summer rain didn't really come at all. So a very difficult season to work with. getting down from 740 back to 440 mil. We add 2018 to the picture. 2018, if we thought 2017 was bad, 2018, which is here in grey, comes up at 360 mil. So a year that made the previous year look good, even though that looked bad compared to the one before it. Moving on again, 2019. So 2019 continued the trend, 330 mil for the year. You can see that the rain, again, it started in May, season's break. Didn't look too bad for a while in the early parts of the season, but never really hit those heights through winter, and very little spring rain, a little bit of summer rain, and finishing the season at 330 mil, which is well and truly below the 600 mil average. You can see that there's only 60 mil of rain, 55 to 60 mil of rain between November and March. So that end of season rainfall here between November and March, very, very little. The 5-year average for this Flaxman Valley site, for the normal 600 mil a year average, the 5-year average for this period was back down to the 500 mil rain period. So even though we had one good year with rain well above average, the rest were well and truly below that. 2020 season, I haven't got the data on here, but 2020 season is looking quite different again. The last couple of weeks, we've seen what looks like a reasonable break. We have 70 mil of rain recorded at Flaxman Valley so far for the month of April. And it's going to be interesting to see how the next couple of months pan out, with the Bureau forecasting above average rainfall. The important take home here is not just on the fact that one year was lower than another, but the fact that we're dealing with quite a bit of variability. Certainly there was a big trend downwards for those few years, but also a trend downwards in the finishing rainfall. As I said, it's going to be interesting to see what happens with 2020, to see if we are back to the kind of decile 5 rainfall, a typical average year, or whether we end up with the year slightly above or slightly below.
Yeah, I guess, Peter, obviously it has been variable, and I guess the way you've graphed it out does show that over those 6 different seasons. It was interesting to see the last 3 seasons, both from the growing season, sort of April to October, but also right through the 12-month period for the last 3 years has been certainly lower than the previous years. And I guess that's part of variability, but makes it sort of, farmers still have to go ahead and manage that variability. So I guess that's the soil moisture picture, but how does that translate to, that's the rainfall, but how does that translate to soil moisture or plant available water for the site at Flaxman Valley?
Okay, so that's the next half of our presentation. So at each of our monitoring sites, we've got a soil moisture probe, and the soil moisture probes record our moisture levels at 10 centimetre increments through the profile. We start with the top centre at 15 centimetres, and then we measure down 15, 25, 35, down to 95 centimetres. So each sensor gives us a figure for the moisture level at that depth. So a 15 centimetre reading of, say, 20% or 25%. What we do then is we sum all of those readings together to give us a figure for the total profile. And then we look at the changes in that total moisture over time to identify the point where the profile is at its wettest. So that's our drained upper limit. And then we look at the point at the other end of the spectrum when the water is at its lowest ever level, which is our crop lower limit. The difference between those is our plant available water. What we've tried to do at these sites is we've tried to look at soil survey information on the plant available water holding capacity from soil tests, and then we've adjusted our figures from our probes to make sure that they line up with the plant available water that's actually been measured. So when we say there's say 50 millimetres of plant available water, that should be a fairly true indication of the water level that's in the profile. So what we've done is start to look at the water in the profile at each of the seasons. Now on this first slide, I've kept the rainfall in here for 2014, just to give you a bit of an idea of what's driving the movement in the plant available water. So the cumulative rainfall is our purple line, and the blue line is our soil moisture. So the total plant available water, what's available to the plants in that time. So you can see the big rain events correspond with increases in soil moisture.
Yep.
And then when the plants are using water, particularly here through the key parts of the growing season, the rainfall is not keeping up with the water that's being used by the plants, and we see the water drying down. You can see the impact here of December rainfall moving the plant available water back up. Same thing in January. Now the flat lining here is in periods where the pasture wasn't actually using any water. We can see here plant available water going up with the January rain. That's where the rain for the season's flatlined. Our soil moisture went through its peak and then just slowly drained away. Now some of that is drainage, but the most of it would be the use of water by either the residual crops or by weeds, whatever green matter was growing on the paddocks at that time.
Actually, just on that, Peter, yeah, Flaxman Valley, as you remember, has got a percentage of perennial grass in there, a phalaris, and that I'm sure would have been utilising some of that water compared to like it was just an annual pasture, where obviously things dry up and aren't growing over summer.
Mm-hmm. Excellent. Thanks, Brett. So you can see one of the impacts here is that at the end of the season, when we reach the end of the season, the soil moisture hasn't got down to the bottom. So the bottom line here is our zero soil moisture. So even with that phalaris taking out some of the water, there's still been something left in the profile. You can see back in April, we started with more moisture than we've actually ended up. So we've taken out more moisture than we started. So let's have a look how 2015 compares to 2014. So 2014 in the blue, 2015 in the red. We can start to think back of what was happening with the rainfall, the amount of rainfall we received when we received it. So we can see the winter rainfalls building up the profile. The profile didn't get as full as it did in 2014. We can see the very strong, rapid rate of drawdown of moisture as the pasture really hit its straps, developed full height, and then a little bit of rainfall here in November, pulling the moisture back up again, and then steady decline here as whatever's residual on the ground is taking away what moisture's left. We came very close to a completely dry profile. And then rainfalls late January, February, March started to pick the profile back up. And we ended the season with more moisture than we started. So a very different plant available water curve because of the different patterns in rainfall between the 2 years. We add 2016. So if we come back 2014, the blue, 2015 added in red, 2016 in the green. So 2016, we can see that impact of the rains coming in very strongly there through June. That plant available water really peaking much earlier than the other couple of years. The profile staying quite flat up towards the top here. Some early drainage through the profile, but generally a profile holding pretty much values. The rain was keeping up with early. If we look back to when spring would have started, August, September, October, we can see that through the start their rainfall was well and truly keeping up with the pasture's use. And right up into here, probably into the second week of October, we had sufficient rain to keep up. And it's only at that point that the pasture started really using more water than the rain was putting in. So the big impact here is dry matter production through that period would have been considerably higher than in the previous years. The pasture was unstressed. There was plenty of available water right through. If we look through here into this period, November, December, more rainfall events topping up the profile, and good solid water use right through November, December, more rain in here and considerable impact of that January, putting water into the bank. So a very, very different picture in terms of pattern, and probably a very good year for dry matter production. I don't have the dry matter production periods here, but it would be good to have a look at that impact on relative dry matter production between the years.
Yeah. So yeah, 2016 a good year. What about the following years?
All right, so 2017, an interesting year. The season break was delayed. Pasture growth slowed down in the middle of November, and moisture levels through then got very low. Why did soil moisture use stop when there was still moisture level though in the profile is probably an interesting question. With the late season break, the pasture didn't get established as early as it had in the other seasons, which meant that the pasture couldn't get its roots right down through the profile. So even though we did see good water use through the period here, it was accessing the water in the top level of the profile, maybe 10 centimetres down to 50 or 60 centimetres, but the plants couldn't get access to the water that was held deeper down. So a bit of an interesting change in terms of the impact on pasture development. If we move on to 2018, we've added the extra grey line here for 2018. The rains came late once again. They were split over a couple of key time periods. There was very little rain between September and November. Mid-November, the pasture was growing rapidly, but the profile was getting very depleted. You can see here through this period, the grey here, that it's getting very close to running out. There was some rains here in the third week of November that put good water back in and allowed us to extend the season back on. There wasn't much left in the profile at the end of the season, so the plants this year, even with that late start, wasn't as delayed as the previous year. The pasture was better able to get its roots down and pull some of that extra water down. If we move on then to 2019, so the black line here, see the impact here that pasture water use continued here right through into May. And this is when the first time we've seen everything get down to the crop lower limit. So at this point, anything that was still around had run out of moisture. There was basically nothing there. The rain events came May, June, July, and we can start to see the profile lift. But again, the wettest point for this season, still well and truly below the previous couple of years. We never got close to capacity on the profile. So the pasture was never going to get as good a start as it would if it had been able to work from a full profile. The rain did continue reasonably well through the growing season. We can see lots of lumps of rain here. So even though there was less, a lot more of it came through later on in the growing season as well. So what does this tell us? It's interesting to then try to do a little bit of thinking about what impact does that have on how you manage. What decisions can you make from it? When do you move stock on and off? When do you work out how much stock you can actually carry? Do you look at this depletion and say, look, we're really pushing our moisture levels very, very steeply here, and we're going to run out of moisture soon. So if you can make a decision a couple of weeks earlier on moving stock on, you can give the pasture more chance to recovery. You might also get your stock out and off to market a couple of weeks before everybody else. There's an opportunity there to take advantage of better prices. If you can see what's happening on your paddocks, that they're running out of moisture, you can make the decision to take the stock off the paddocks and take them to market early. if we've got moisture left in at the profile at the end of the season, does that give you an idea of maybe changing what you're growing, how you're growing it, to try to take advantage of that moisture that's left?
Yeah, I guess just on that, Peter, like, yeah, maybe in sort of in your summer months, you might have a chance to even put in a summer forage crop if you thought that there was adequate moisture there, plus the forecast looked reasonable. It's an opportunity to do that too.
Exactly, exactly. All right, so that's a bit of a wrap up of firstly the rainfall trends between 2014 2019 and of the plant available water patterns from 2014 to 2019. So Brett, do you want to give a bit of a wrap up?
Sure. Look, I guess it's good to see certainly those variability in that rainfall and that soil moisture. You know, it can be it's obviously quite variable. And I suppose sometimes it does relate to rainfall, but it's also to do with runoff a bit for plant water use. It's also, so it could be related to that. Also, I guess just from the point of view of managing it, I guess managing that variability just does highlight too the importance of being able to measure and being able to see those, particularly the soil moisture levels, and particularly in early spring in terms of making decisions. Like our producers want to know stocking rates is very important for producers, and having knowledge about that. But you know, if you're going to cut out early, relating that to soil moisture, then relating that to production. Obviously, as you highlighted before, if you can get them off early, that's also got ramifications for ground cover going into summer, which from an NRM point of view is pretty important. But other than that, I think that's nice to see that comparison between what you've shown us, Peter. Do you want to add anything to that before we finish up?
I think in a lot of cases this comes back to producers have really good intuition and gut feel. They have a really good understanding and working knowledge of their properties that's gained through years of experience on the land. If we can provide some information from sensors that helps back that up, reinforce it, but also sometimes to help challenge it, so they can maybe look for opportunities when their intuition might be telling them the wrong thing. It's a bit like a pilot flying into a mountain that he thinks is just white snow in the horizon. Sometimes your intuition can point you the wrong way. But if we can, through sensors, give you additional information that helps you ground truth what you're seeing and help you identify variations and changes, then I think we can use the technology to help informed decisions be made. And that's what we're about trying to do. Just give you more information. We don't want to come out and say this probe or this rainfall monitoring can take the decisions out of your hands. We're just trying to give you information to make better decisions and to make you better able to cope with the variability that we know is part of the changing landscape that we're all operating in.
Yeah, and I guess I agree. It's another tool to make decisions, and it also, I guess, highlights the whole adage about you can't manage if you're not measuring it. And so, yeah, let's leave it at that, Peter. Thank you very much for your insights and dissection of the data. Thanks to Adelaide Mount Lofty Ranges NRM board for sponsoring this project, funding this project. If you'd like any more information about BIGG, check out our website or also visit our Facebook. Thanks very much.